Hi everyone, in this video I'm going to go through 3 questions with you. So what I'd like you to do is look at this one here, pause the video, have a go at it on your own, see if you get it right, okay? So pause the video now. Okay, so let's see how to do this question here. Okay, first of all, get into the habit of making little dashes on lines if you know 2 lines are the same length. So for example here, I know O to B is a radius line, O to D is a radius line, so this line must be the same length as this line, okay? And if you put those dashes in, it's easy to see what to do now, because look at what we have. That means OBD is an isosceles triangle. So this angle is 50 degrees, so this angle here in red must be the same as this angle here. So we can easily now work out what y is. So we need to do 180, take off 50, divide that by 2, and this is what y is equal to. That's 65. So y must be 65. Okay, so get into the habit that if you know for a fact that 2 lines are the same length, put that dash in there. And then it just makes it easier to see what to do. Okay, so OB, OD, same length though. Put a dash in. Oh, look, we've got an isosceles triangle. 180, take away 50, half it, 65. And by the way, this is also 65, so let's write that in there. Okay, now we need to start using some of our circle theorems. Okay, this ABC is a tangent line because it only touches the circle once. OB is a radius line. What angle does a radius and a tangent meet at? They meet at 90. Okay, so that means this entire angle is 90. So that means Z must be equal to 90 take away whatever Y is. Okay, well Y is 65, so 90 take away 65 is 25. So now we have Z. Z is 25. Okay, done. Now, okay, that leaves X. How do we find X? Well, notice that we have a triangle here that contains X and Z in the same triangle. Okay, but in order to work out what X is, we need this angle here. Okay, well, look at it. CDO is a straight line. What do angles on a straight line add up to? They add up to 180. So 180, take off the 65, is going to get this angle here in this corner here, which is 115. So that's 115. Now, in order to get X, remember, angles in a triangle add up to 180. So X is equal to 180. Take away 115, take away 25, and that's going to give us what X is. So we can work that out now. Which is, oops, I made a right mess, sorry, which is 40 degrees. Okay, so that's what the angle is, 40 degrees, and I hope you got that as well, okay? So we only had to really use kind of like 2 facts really about that one. Okay, right, this one is a bit tricky. Oh no, actually, is it tricky? I don't think it is. Well, that's me anyway. Okay, have a go at this question and see if you can get it right. Okay, so pause the video, have a go. Okay, guys. Okay, so the first one, BAC. Sometimes it's hard to figure out which corner they actually want you to find the angle for, but it's BAC. If you kind of draw them out, it would be this angle here. So that's circle theorem number 1. The angle at the center is always twice the one on the circumference. So this has just got to be half of 2p, which is p. So this equals p. Now, this next one is it's a bit tricky to spot this one, but it says find the angle XCA. So XCA is this outside angle here. Now, I had to think about this one myself, but then I just spotted what the solution was. Notice you've got this giant triangle here. Okay, this giant triangle, and then you've just worked out that that angle is P and that angle is P, so it's easy to work out what the third one is here in a triangle, because it would be 180 take away the other 2, because angles in a triangle add up to 180, and also because they're both the same angle, that triangle is also isosceles, believe it or not. But this angle in green would be 180 take away 2p, because this is p and this is p. Then notice that XCY is a straight line, so this one here would be 180 take away the one we've just worked out. So we need to do 180 minus, and then you have to really open a bracket and put 180 take away 2p like this, because this shaded in angle is that expression. So we need to do 180 take away that expression, and because it's not just one thing, it's two things here, we should really write it in the bracket and then really think about how to expand that bracket. So it'd be 180 take away 180, but that minus there is going to turn that minus into a plus, so it'd be plus 2p, and then 180's cancel each other out, so this would be 2p. Okay, so we've just worked out that that is 2p. Okay, now I'm not going to lie, that was a bit tricky, that one, but the trick is to do 180 minus this angle here, which is 180 minus 2p, and you really should, if you're subtracting more than one thing away, you really should kind of put it in a bracket, because that minus turns that minus into a plus, and the 180 and that 180 effectively cancel each other out, they're taken away from each other. Okay, so the last one's probably the easiest one, because you've just worked out Xca. So I want you to work out ACO, which is this tiny angle there. Okay, now just remember, a radius and a tangent meet at 90 degrees. You've just worked out that this angle is 2p. What was it again? It was 2p, wasn't it? So then ACO would be 90 take away 2p. So this is the angle. Okay. Now, by the way, it's all algebraic, so they can't unfortunately simplify that really, unless you want to introduce a bracket, but you're causing more work than is necessary. But that's it. So it's p, 2p, and then 90 take away 2p. Okay, last one. Right then, so have a go at this one here. You might want to pause the video now and have a go. All right then, let's go through this one then. So what do we do? Okay, first of all, this picture is very badly drawn, and it's massively confusing because of the way it's drawn. But EOC is a straight line, and ABC is a tangent where that straight line meets this tangent. So that there is technically a 90-degree angle, which it does not remotely look like a 90-degree angle, does it? But these things are never drawn accurately, but it really should be better than that, really. It's not very clear, but that might help you do this, or see how to do this problem now. Okay, so let's find X first of all. Now, X is the easy one to find, I think, and there's two different ways to do it. First of all, it's just double 35, so X is 70, okay? Because the angle at the center is always twice the one on the circumference, because they come from the same positions here. Or another way to do it is OC and OD are radii, so you can put a dash and a dash. So this angle here is 35. So together, 35 and 35 makes 70. So this angle here must be 180 take away 70. That's 110. So then X is on a straight line with that 110. So X would equal 180 take away 110, which is 70. Okay, that's two ways to find X. Okay, so how do we get to Z and Y? So that's 90 degrees there. Okay, the way I got Z is really simple. Notice this position and this position are the fixed points, and this angle would be the same as the one up here, 35. Okay, because they're both drawn from the same positions. And then notice you've got a giant right angle triangle, which doesn't look remotely like a right angle triangle. So then you've got 90 and 35, so Z's got to be 55, because 90 take away 35 is 55 degrees. So that's 55 degrees. Oops, 55 degrees. Okay, so that's Z done. And then you could do the same thing again for the Y. So the way I found Y was I put a right angle here, and then notice that it's in a triangle with X. No, I can't remember what X was. Oh, it's up here, 70. So that's 70. Right angle, so Y's got to be 20. So that's how you do it. The thing about this particular one is it's very badly drawn. It's really... that should look more like a 90-degree angle than it's currently drawn, because a radius Remember, radius and a tangent always meet at 90, so it's always a good idea to draw things in if you know them for a fact. Okay, so thank you for watching this video, and remember, I'd like you to have a go at this code breaker, and then maybe you can email me the coded message, because I can't actually remember what it is. It will be a message, it's not going to be gobbledygook. And remember, there's 2 messages for you to solve, so have a go. Thank you very much for watching, guys.